Hello, everyone. In this video, we're going to continue our work in section 3.7 with our business applications. So before looking at these examples, I just want to go over a few formulas that we will need. So in Math 147, we saw these formulas here for determining the amount of money in an account that collected interest. So in these formulas, we were looking at interest that accrued continuously. So P is some principal investment amount. And then how does that account grow continuously? So E to the power of R, which is our interest rate, times the amount of time. We also looked at accounts that accrued interest or compounded interest in different chunks of time. So here I have an example of, or here chunk of time would be kind of an amount, increments of N. So maybe quarterly, maybe daily. And so we had a formula here. Now, again, these are great formulas, but again, they assume that we started with a principal investment and then don't make any more contributions or taking money out of the account. So to change that up, we have some new formulas that we can use for when our income maybe changes. So we put in more money, we take out money, and we can do that because we're now using integrals. So let's look at these two formulas here. So PV is present value in an account. So I'll write that out here, present value at time t equals, we'll say t tilde. So that's our upper limit of integration. So t tilde is some fixed constant that we're determining, or that we have input into this function to know what the price is at that time. Okay, so what does this function mean? So this is the integral from 0 to that time, t tilde, of f of t, where f of t is our income flow function. I'll write that out, income flow. So that income will change based on what t is. So that's why it's a function of time t. And then we take that times e to the negative rt. So r here is, again, our interest rate, and t is a variable in this integral. So that's the present value of an account. So if you are interested in knowing, well, how much is in my account at time t is 20 years, we can compute an integral like this. Then we can also find a final value in the account. So that will look like the following. So f dot v, final value. This is at some little t given here. Well, that final value will be the present value times e to the rt. So that's where we're getting that more interest compounding. So we're multiplying by e to the rt. But in general, there can be more complicated functions than this, but for this class, this is going to be that function, or that formula rather, that we're going to look at when we compute a final value for an amount of money in an account. All right, so take a moment to pause the video and make sure you have these new formulas written down. And when you're ready, we'll start to look at some more examples. All right, so example 7 says, you have an opportunity to buy a business that will earn $75,000 per year continuously over the next 8 years. I'm just going to highlight some things here. So it will earn $75,000 continuously over the next 8 years. Money can earn 2.8% per year, compounded continuously. Is this worth its purchase price of $630,000? So what I'd like you to do is pause the video and just process this information for yourself. So reread this prompt, maybe make some scratch notes for yourself to try to understand what this business proposal is. Okay, so let's talk it out a little bit together. So what's going on here is that this business that we might buy has a present value at the moment. So the present value we'd want to compute using this present value formula. So from there, we can then determine what the final value of that business should be over some amount of time to determine that if we take on the business at its present value, is it going to be worth that price that we're buying it for eventually? All right, so first let's set up that present value of the business. So let's first identify everything that we have here. So we have our income flow function, F of T, is going to be equal to 75,000. So that's how much money is coming in per year. Our interest rate is equal to 2.8%, which is equal to 0.028. And then the time where this business will earn this money will be 8 years. So that T twiddle is 8. So now let's set up that present value of the company. So we have the integral from 0 to 8 of 75,000 times e to the negative 0.028 t dt. So take a moment, pause the video, make sure you're caught up here. And when you're doing that, also take a look at computing this integral in your calculator. When you're ready, let's look at it together so we can compute that integral. I'm going to just get a new line here. So we want to compute the integral from 0 to 8 of 7,500. We have e to the power. Oops, I don't want 2 there, so I'm going to back up here. To the power of negative 0.028 times t. Need to make sure we stay in that exponent here. So to do that, I'm going to put parentheses so it knows. Here we go. And then ending with dt. And so we're getting 537,548.747. So we're just going to round up. So I'm going to write that down on our notes. So what we're getting here is it's approximation because we're going to round here. So 537,548.75. So that's the present value of the business. So how we should be interpreting that present value is that if this company for the next 8 years is going to bring in that 75,000 a year and collect interest, then its worth is going to be $537,000. So if we are being sold this business for $630,000 rather, we see that purchase price isn't worth that present value. So we would say, no, this is not worth the investment. No, not worth investment. That's because the purchase price is greater than the present value. All right, great work. We just have one more example to go. Thank you for watching.